Kroger.
And I'm Gerster.
And we are your newscasters for Deeds Bio 121.
Good morning and welcome back to another wonderful Thursday morning newscast. We are glad to have you all join us this morning.
On today's episode, we will be covering some hot topics: final exam review, tips for not failing the final exam, studying like biologists' favorite Christmas movies, and Professor D's Christmas list.
You're going to want to stick around for this one.
But first, I have a joke to start off our morning.
Oh boy, let's hear it.
What did one cell say to his sister when she stepped on his toe?
I have no idea.
Mitosis.
Well, on that note, let's dive right into the final exam review. Since this is our last
Hold on. Just in breaking news, the genetic disease purine nucleoside phosphorylase deficiency has new important information for our viewers to be aware about.
Oh great, this is my favorite genetic disease to learn about and teach. So purine nucleoside phosphorylase deficiency is a rare disease that affects the immune system and causes immunodeficiency.
And let's not forget that immunodeficiency is a condition where the immune system is not able to protect the body from viruses and bacteria.
Yes, but anyways, T cells are types of cells that protect the immune system from such invaders like bacteria and viruses. People with purine nucleoside phosphorylase deficiency have very low numbers of T cells.
Don't forget about B cells that produce immunoglobulins to fight off infections that attack the immune system.
People who have purine nucleoside phosphorylase deficiency and also lack B cells have a serious condition that is called severe combined immunodeficiency, or commonly referred as SCID.
This disease is caused by a mutation that lies in the purine nucleoside phosphorylase, or PNP gene, and is inherited through autosomal recessive manner. This means that two traits of this gene must be prevalent in individuals in order for it to be passed through families.
This disorder is caused by mutations in the PNP gene, which is located at chromosome 14q13.1.
PNP metabolizes inosine into hypoxanthine and guanosine into guanine, which creates the ribose phosphate.
Only 70 cases have been medically reported, and they all come from Europe. It is an extremely rare disease.
Now that we know what this disease is, let's send Haley to go interview a doctor who knows more about this disease.
But first, let's take a short break.
Because we're PNP, phosphorylase, TNT, deficiency, TNT, Professor D's, TNT, genetic disease.
Welcome back. We're here with Dr. Gerster, who is going to further explain our disease, PNP. Dr. Gerster,
Hello.
thank you for coming.
Thank you.
So, Dr. Gerster, can you tell us more about the symptoms of this disease?
Yes, I'd first of all just like to thank you for having me on your show today. So some symptoms of purine nucleoside phosphorylase deficiency include stiff and rigid muscles, so like you don't have full range of motion in particular limbs of your body. And then another common symptom would be uncoordinated movements or even spasms. So it could be muscle spasms mainly. And so all neurological symptoms that even could be developmental delay.
Okay, so now can you explain to us the amino acid substitution for this disease?
Yes, so point mutations leading to amino acid substitutions were found in both alleles. One point mutation led to a SIR-to-GLY substitution at amino acid 51.
And how many mutant alleles?
So there's two of them, so it is A174P and G190V, and those are the two alleles that undergo mutation.
Okay. Now that we know more about the specifics of purine nucleoside phosphorylase deficiency, we can go back to the newscast. Thank you so much for your time today, Dr. Gerster.
Thank you for having me.
A short message from our sponsors.
My deficiency, don't want none unless you got genes, hun. PNP is the gene that we need. Some symptoms may include uncoordinated moves, neurological symptoms, developmental delay.
No full range of motion in particular limbs.
Now that's real. Mutant alleles, hot amino acid. Who want to know more? I'm talking acid substitution. Deficiency of some immunoglobulins like SCID.
By the way, what did she say? I can tell she ain't missing studies. Come here and listen to our genetic disease, purine nucleoside phosphorylase deficiency.
And I'm telling you it's real that we love our PNP. Is it inherited or recessive? Immunodeficiency is very, very rare. Like dun 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 dun. My deficiency
don't. My deficiency don't. My deficiency don't want none unless you got genes, hun. Oh my gosh. Look at her jeans. Oh my gosh. Look at her jeans. Oh my gosh. Look at her jeans. Look at her jeans. Look at her jeans.
I hope you enjoyed that short intermission. Welcome back to the newscast, and thank you for staying tuned with us while Haley interviewed Dr. Kroger. Haley, what did you think?
Well, Dr. Gerster definitely knew what she was talking about, and I believe that I learned more about the genetic disease than I knew before we started this.
Well, I hope all of our viewers learn a little something as well. With that being said, I think we have time for one more joke before the show ends.
Fire away.
Why couldn't the plants escape prison?
Enlighten us.
Their cells were surrounded by walls.
Alrighty then, thank you for joining us today, and we will have a final message from our sponsors.
Until next time, D's Bio 121.
If it hadn't been for this genetic disease, I'd been treated a long time ago. Where did you come from? Where did you go? Where did you come from? Genetic disease.
If it hadn't been for PNP gene, I could have skipped 2 traits of this gene. Where did you come from? Where did you go? Where did you come from? PNP gene.
If it hadn't been for mutant alleles, a new genetic sequence wouldn't occur. Where did you come from? Where did you go? Where did you come from? Mutant alleles.
If it hadn't been for Professor D's, this project would have never been seen. We won't be there next Thursday. Good luck on their final exam.